Yes, Dinali and Akshash, you both are present there. Dinali and Akshash both are there. Can you please type the message? Okay, then we can start the chapter force and pressure. So very important chapter. Base. This is a base, okay, of physics. So we have to discuss here force and pressure. So we are doing line to line study for this chapter. Okay. Is Akshash there? Okay. Here, if you have a textbook with you, keep a textbook in front of you. Now, here they are saying, do you recall how can decide whether an object is moving faster than other? What does the distance moved by the object in a unit time indicate? You also know that a moving object like a ball rolling on the ground slows down. Sometimes it may change its direction of motion. It also possible that the ball may slow down and also change the direction. Have you ever wondered that makes the object slows down or go faster, or it change its direction of motion? So here we can take some examples. Okay, suppose we are on the ground and we are playing with the ball. Sometimes many balls are lying on the ground. Okay, that means they are at the rest condition. Rest condition means what? They are not moving here and there. And some players will come and they can kick the ball. Then ball will what? Started moving from that place. That means that ball will become what? In motion. Okay, so ball will become in a motion. Initially it is at rest, then after traveling certain distance its speed is what going to be slowed down. So as the speed is what going to be slowed down, then slowly it will become to the rest condition. Okay, so slowly it will become what? To the rest condition. So who will do this? Who will make it move faster? Who will make them to become slower and slower? Then after that they are coming to the rest condition. Okay, so that everything we have to discuss in this chapter. So next paragraph is given. Let us recall some of our everyday experiences. What do you do to make a football move? What do you do to make the moving ball move faster? How does goalkeeper stop the ball? A hockey player changes the direction of moving ball which a flick of the stick. How do fielders stop the ball hit by the batsman? In all these situations, the ball is either made to move faster or slower, or its direction of motion if changed. We often say that a force has been applied on the ball when it is kicked, pushed, thrown, and flicked. What is the force? What can it do bodies to bodies on which it is applied? We shall seek answers to such questions in this chapter. Okay, so here just now we discuss as the ball moving faster. Okay, then the moving ball we can able to stop. If the ball is in a rest condition, then we can make it move. Suppose the batsman hits the ball, then bowler can hold that catch. Then hockey players, by using their stick, they can change the direction of the ball just by flipping. Okay, just by flicking the ball with the stick. Okay, so who everywhere, if we want to try, if we want to find out the answers, who will make the object move faster, who will make the object to become rest, who will make to change the direction of the object, so everywhere the answer comes the force. Okay, so even ball is also moving on the plane path, and after covering certain distances it will become to the rest. That means there is a force which is responsible to make it rest. Force is responsible to make the direction or to change the direction of the object. Force is required to move the object from the rest condition, or the moving object is there that wants to be a rest, and this everything is possible only because of the force. Force is nothing but push or pull activity, okay, or action, and push, that is force is nothing but what, any object is kicked, pushed, flicked, okay, thrown, so everywhere there is what, force is present. Okay, so force, any object can be pulled, okay, or pushed, and because of that object will become rest or in motion. In that force, that action is nothing but what, the force. Okay, this is the introductory part of this chapter. So if you observe the diagram in your NCERT textbook, okay, so if you check that there are total 3 images are given, pictures are given. Okay, try to learn that pictures. So in first picture, the goalkeeper saves the goal. Okay, second is what, the hockey player, he used the hockey stick to move that ball, or it can move, or it can change the direction. And third picture, the fielder is what, holding the catch. Okay, the ball is what, hitted by the batsman, and he is holding that catch. Okay, Akshash, are you there? Akshash, are you there? Okay. Dinali, are you there? Dinali? Okay. So here in first picture, the goalkeeper saves the ball. Okay, that means he is taking his both the hands, and with the both the hands or palms he is what, opposing to the flow of the ball. Okay, so ball will what, get stopped. Then with the help of hockey stick he just flicked that, he can flick the ball so that it changes the direction, or suppose the body, that ball is in the motion, it can we can able to stop by using that stick. Then third picture is that the bowler is what, just by using their both the palms they are holding the catch. That means object initially it is in a moving condition. Once you hold the catch, that means the object will become what, rest in condition. Okay, getting this up to here. So this is the introductory part. So now we are moving towards the 11.1. 11.1, force, a pull or push. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing and pulling are often used to describe certain tasks. Each of these actions usually results in some kind of change in the state of motion of an object. Can these terms be replaced with one another terms? Let us find out. Okay, so actually the force means, force is nothing but push or pull activity. If we are pushing or pulling or kicking, hitting, lifting, okay, flicking, shutting, opening, picking, anything, these all actions are only possible because of the application of the force. Okay, so check here, if you comes to the page number 128, there will be a table, that is activity is given. What is that activity? So we know that we just now learned force is responsible. Force is nothing but push or pull activity. Okay, picking, dropping, flipping. Okay, that all are nothing but what the examples of the force. Okay, so activity 11.1, I will read it down. Table 11.1 gives some examples of familiar situations involving motion of objects. You can add more such situations or replace those given here. Try to identify action involved in each case as a push or pull and record your observation. One example has been given to help you. Okay, so here the action table 11.1 is given what identifying action as a push or pull. Okay, so here first column is serial number, second column is a description of the situation, then third column is nothing but action, different action, pushing, pulling, then picking, lifting, lowering, flying, kicking, etc. And last is action can be grouped as a push or pull. Okay, like that we have to do. Then first example they gave, I will explain first example. I will give you 1 minute to solve the remaining one, and then we can verify the answers. Okay, first one they are saying here, moving a book placed on the table, moving a book which is placed on the table. So when the book will move when we are applying force on it. If there is a no force, that book will not be moved. See, if I am holding this book with me, okay, I hold the book like this and I set it like that. Okay, if I am pressing here, then this book will what move. Getting this? Okay. Or for example, I will keep this pen on my hand. I'll keep it like this only. I am not at all moving. But here suppose if I am applying force, then the pen will come front, no? Correct? So if we are applying force, the pen is what started moving. Book also, if we apply the force, it is started moving. So moving book placed on the table, then which action will take place? Yes, if it is moving, that means maybe there is a pulling, pushing, maybe lifting. Okay, so then action can be grouped as push, yes, pull, yes, maybe pushing is there or maybe pulling, because in both the cases it is what moving. Understood? So next also I will explain it. Okay, so second one, opening or shutting a door. Okay, just we have a doors, no, like this. Suppose this is, you can take this as a door. This is I am opening and closing, opening and closing. So here there is what, pushing, yes, pulling, yes, we are not lifting. Correct, we are not lifting the door. Correct, so lifting dash will come. There is a push pull activities, means fourth, yes, it is pushing action as well as pulling action. Because see, in many of the offices or in many of the shop, they are saying the door should be pulled, door should be pushed, they are writing over there. Okay, so I'll give you 1 to 2 minutes, you can find it out, 3 4 5 6 and 7 options, and then we can discuss. Okay, do fast. Finish that? Did you finished? Okay, so here activity is given. Next is third one, drawing a bucket from the well. So that is what? Pulling, not pushing, also pulling. Okay, so we thrown that bucket into the water, we are taking up. Okay, that is pulling. Okay, as well as lifting, both. No pushing, but here pulling and lifting is there, and group of action only push is there. Okay, next one, a football player taking a penalty kick. Penalty kick means what? He is just kicking. Okay, and he is what? Pushing that object. Okay, that I don't know, sorry. If that is related to CBSE, then I can give the answer. So here there is pushing as well as kicking, and action is here pushing. Okay, the next is a cricket ball hit by the batsman. Cricket ball is hit by the batsman, then which action will take place here? He is pushing, correct, as well as he is hitting. Okay, so there is option is there hitting, and here only pushing, no pull action is there. Okay, now next one is moving a loaded cart. There is what? Moving a loaded cart, that means that is pushing. Okay, then that is picking, yes, and only pushing action is involved over here. Then opening of a drawer. Opening of a drawer is only pulling action. Okay, and yeah, opening action, that means that is pulling. Okay, that's it. This is what the table. I hope you all are tick marked or wrote this. Okay, if you copied or if you did everything, then I will go to the next part. Okay, just give me 2 minutes. Now, next one I will read out. Do you notice that each of the actions can be grouped as pull or push, both? Can we infer from this that to move an object it has to be pushed or pull? In science, a push or pull on an object is called as a force. Everyone can underline this. In a push or pull on an object is called as a force. Thus, we can say that the motion imparted to objects was due to the action of force. When does a force come into play? Let us find out. Okay, so from this we will come to know that the force is nothing but push and pull activity. Okay, if you are applying a force on any body, that object can move, that means there is what? Force is application of force is there. Now here force is responsible for other what actions, that also we have to discuss. Okay, and when the force will come into play, that also we have to discuss. See, always remember, whenever there is a force is there, that means there is push or pull action is present on the body. Either body is moving in the forward direction or in the backward direction, or if the body is at rest, it will become in a rest. If the body is in a rest, by application of a force it can move. If the body is in a motion, then it can come into the rest just by application of the force. Okay, and 100% there is a definition will come. What is a force? Force is nothing but push and pull activity on an object. Okay, now come on the page number 129. Okay, so in 129 they gave in 11.2, suppose a man is standing behind a stationary car. Stationary car means what? That car is in the rest condition. Stationary means what? It is in the rest condition. Okay, there is pictures are also given. And will the car move due to his presence? Suppose man can now begin to push the car, and that is, he applies a force on the car, on it, and the car may begin to move in the direction of applied force. Note that the man has to push the car to make it move. Now here check. In first figure, that yellow shirt person is standing behind the car and one person is sitting in the car. So initially the car is at what? Rest condition. Car is not moving. That man is simply standing. He is not applying force on the car. But in second picture, if we observe here, that the person who is outside the car, he is what? Applying the force on the car. Okay, and whenever he applies the force on the car, then car will what? Move in the direction of force. Okay, and here two girls are there. Who is pushing whom? So both are what? Pushing each other, so that no one is moving. That force is what? Get nullified here. So figure 11.3 shows three essential that may be familiar to you. Can you decide who is pulling and who is pushing in these cases? In figure 11.3, both the girls appear to push each other, while the pair of girls are trying to pull each other. Similarly, the cow and men in 11.3c appear to pull each other. The girls in the two situations shown there are applying a force on each other. It also true for the man and cow. Farmers, from these examples, we can infer that at least two objects must interacted, okay, or for a force to come into play. Thus, an interaction of one object with another object result in force between the two objects. Okay, so it's very clear statements are given. If you observe, if you know, if you will come to know that first two pictures, okay, figure 12.11.2a and 11.2b. So initially car is at rest. When you apply the force, then car will move in the direction of force. Now here two girls are there. They are fighting with each other. Each one is pulling to each other. The object will remains in the same position. They will not move here and there. And in second case 11.3b, who is pulling whom? They both were what? They both were what? Pulling each other. Okay, and they are moving. That's it, on the same place. They are not going somewhere else, because both are applying same force and same force. So action is also same. Each one is trying to pull with each other, but they cannot come closer to each other. Okay, this is one kind of force. And here if you observe 11.3c, the man is pulling the string which is given to the cow. Okay, that is not coming. That is what? Taking. That is that cow want to go back. Okay, and this farmer want to pull them front. So there is both pulling and pushing is there. By just observing the picture, we'll comes to know that. So whenever there is a high strain, high tension is there. See that string which is there in the cow's neck. That person is trying to pull very hardly. That string is straight. That means he is applying more force over there, but that cow don't want to come to there. Okay, this is what page number 129. You can read. If you have a doubt, you can ask me. I'll give you 1 minute to read out all these things. I'm here only. Yes, can you able to understand this? Can you getting this up to here? Does anyone having doubt? Now we can go towards the page number 130. Okay, so exploring forces. Let us try to learn more about forces. Activity 11.1. I will read out. Choose a heavy object like a table or box which you can move only by pushing hard. Try to push it all by yourself. Can you move it? Now ask one of your friends to help you in pushing it in the same direction. It is easier to move it now. Can you explain why? Push the same object, but ask your friend to push it from the opposite side. Does the object move? If it does, if it is, if it does, note the direction in which it moves. Can you guess which one of you is applying larger force? Okay, so if you observe the figure 11.4, in first case, two children or two kids are applying the force on the wooden block in the opposite direction. Okay, once is applying a force on the right side, another is applying a force on the left side. Means suppose if I have a book this and I am applying force on both the sides, the object will not move, okay, from its place. The object will not move from that place, because both the friends are of having same ability and both are what pulling that, both are what pushing that. So the object cannot move, that will remains as it is. Okay, so that is in figure B what I explained. And in figure A, both are applying a force on the same side, that means object can move from one place to another place, that means force will come into the picture. But in second case, force is what get nullified, that is very important. Okay, force is what getting nullified in picture number 2, and in picture number 1 the force is what they both are applying the same force in the same direction. So magnitude of a force is what get increased. Magnitude is nothing but what volume of the force. Getting up to here, read up to here once the activity. I hope everyone did this. Yes, who is there? Hi. Okay, now here, that means here we learned force is a push or pull activity. Okay, and in 11.5 people are playing tug and war. Okay, so in one side three kids are there, in another side also three kids are there, and they are applying equal amount of force so that no one can moving. Okay, they are at the same place. Okay, so one force will become weaker, then the other people can pull them. Okay, so like that, this tug and war, they explain the force effect of a force with the help of tug and war example. Okay, so here they are saying, have you ever seen a game of tug of war in which game either two terms pull or pull at a rope in opposite direction? Members of the team try to pull the rope in their direction. Someone the rope simply does not move. It cannot similar to the situation which is given 11.3b. That same team that pulls harder, that is applies a larger force, finally wins the game. So according to the first figure from 11.4, not 11.4, yeah, 11.4b, so both forces are applying in the opposite direction, they are getting nullified and they will not move here and there. Okay, but here they gave, but if suppose if anyone works very harder, then there is a chances to win that game. Now here the force applied on the object in the same directional add to one another. Now recall what happened when you and your friend pushed a heavy box in the same direction as an activity. So we have one heavy box and we want to take them into the corner. So we are applying a force onto that, we are pulling action we are doing, and that we are taking into the desired place. Okay, so now next, if two forces acts in the opposite direction of a object, the net force acting on it is difference between two forces. Underline this statement. If two forces act in the opposite direction of an object, the net force acting on it, the difference between the two forces. What did you observe in the activity 11.2 when both of you were pushing the heavy box from the opposite direction? Recall that the tug of war, when the two teams pull equally hard, the rope does not move in any direction. So we learned that force could be larger or smaller than the other order or equal to each other. Okay, underline this. We learn that force could be larger or smaller that the other or equal to each other. The strength of each force is usually expressed in terms of magnitude. Force का magnitude भी दिया जाता है. Magnitude means its value. Okay, and it also specifies the direction in which the force acts also. Okay, if the direction of force or a magnitude of the applied force changes, the applied effect is also what gets changes. Understood here? Okay, in general more than one force may be acting on the object. Okay, however the effect on the object is due to the net acting on it. Okay, मैंने object कहाँ रखा है and how many forces acting on that object is nothing but total force acting on it. Okay, and each force is what comes with the magnitude. Okay, as well as it is indicated by the direction also. If equal and opposite forces are there, they are cancelling with each other, but the two or more forces acting on the same side, then they can move from one place to another place. Can you getting up to here? Okay, so read properly up to here, then we'll go for 11.4. Okay, do fast, I am waiting here. Okay, finished. I hope everyone is getting up to here. Okay, now force can change the state of motion. Yes, force can change the state of motion. Suppose if I kick the ball, okay, then that ball is what traveling on that path. So someone comes and they can stop that ball. Okay, that ball will become to the rest. Suppose the ball is in the rest condition, someone comes and kick the ball, that means the ball is in motion. Suppose if I have a chapati dough, okay, and if I apply the force and if I am changing my finger action, then it changes its shape, okay, and it changes its size whenever we are rolling it, okay, with the help of rolling pin, then there is a shape is also get changed, correct? So with the help of force we can change the direction. If object is moving, then it will become to the rest. If the object is in the rest condition, it is what moving, and because of application of a force they can change their shape and size. Can you getting? So this is nothing but what? Force. So sometime they will ask the question, what do you mean by force, and what are the specification of force? So to write, force is a push or pull activity, and because of this push and pull activity we can change the direction of the ball, or if the ball is in a motion we can make them into rest, and we can change the direction, as well as we can change the shape and size of the object by the application of force. Okay, so this is nothing but what? Force. Very important thing, many times questions will come. Okay, so yeah, if you observe here, activity 11.3. Activity 11.3 is what? They are saying take a rubber ball and place it on a level surface such as tabletop or concrete floor. Now gently push the ball along the level surface. Does the ball begin to move? Push the ball again while it's still moving. Is there any change in its speed? Does it increase or decrease? Next, place your palm in front of the moving ball. Remove your palm as soon as the moving ball touches it. Does your palm apply a force on the ball? What happens to the speed of the ball now? Does it increase or decrease? What would happen if you let your palm hold moving the ball? So initially what, I have a tabletop and I am just throwing a ball, so it can moving on the tabletop, on the plain tabletop it is moving. Suppose the surface will become harder, and again if I am throwing with the same speed, it can cover some distance and it will stop, no, because the surface is not regular, it is a irregular surface, so it is what, get its speed is get decreased. Okay, so now someone is thrown the ball and I hold the catch, then ultimately ball speed will become what? 0. Then ball will become at a rest condition. That's it. This is activity 11.3. So now if you take a figure, if you check the figure 11.7, okay, I have, that is what is given, check that I have seen children competing with one another in moving a rubber tire or a ring by pushed it. Now understand why the speed of the tire is increased whenever it is pushed. So here one tire is there, okay, and with the help of stick they are applying some small force, then that tire is what started rolling, okay, and it covers some distance. If you keep on applying force and it moves faster and faster, they acquire more speed, and that wheel is what comes into the motion. Okay, if you try to, if you are not applying force, then it will becomes to what? Rest condition. Okay, so these are the effect of the forces. Can you getting up to here? Does anyone is having any doubt? Can they message if they have a doubt? Yes, Denali, do you have any doubts? If you have any doubts, can you message? Yes, does anyone is having doubt? Denali, are you there? Okay, now we'll go for the activity 11.4. Okay, I'll explain you this activity with live example. So if you have a ball, you just hit that ball on the wall. What will happen? It break the wall, and can it pass from the wall? No. It can hit the ball on the wall and again it come back. Correct? So come back means what? Whenever the ball is going from me to wall, then it will come from wall to me. Okay, so that means what? There is a change in direction. Akshash, I am calling you from long time. Can you able to hear me? I am asking from a long time. Okay, no issues. So we can use the force to change the direction also. Okay, on page number 132, if you check that second column above that orange color strip, there is a note given. Underline that statement. A change is in either the speed of an object or its direction of motion, or both, is described as a change in its state of motion. Thus the force may bring change in state of the motion of an object. Okay, from long time I'm saying the force is used to move the object. If that object is in a rest, the object is in a rest, then we can use to move that, or moving object we can keep it. Okay, we can rest it. Okay, as well as we can, force is used to change the direction just by using hockey stick. You are flicking what? You are flicking the ball direction. Okay, then after that we can change the shape and size just by kneading. Means whenever we have a chapati atta or dough, we have that dough, if you press it, then it can change its shape, no? Correct? So that is there. So it can, thus the force may bring a change in state of motion of an object. Okay, understood up to here? So now next, state of motion. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be a state of zero speed, and the object may be at rest or in the motion, both states of motion. Means object, if it is in a rest, okay, that is also one state of motion, and the body or object is moving, that is also one state of motion. In the rest condition or in stationary condition, body is at the same position, it is not moving here and there. Can you getting up to here? Okay, now here yeah, on page number 133, force can change the shape of the object. That is true. Just now I explained you with the help of chapati atta or dough. So there is activity 11.5. Check that. What is the 11.5? So some situations have been given in column 1 of table 11.2 in which objects are not free to move. Column 2 of the table suggests the manner in which the force can be applied on each object, while column 3 shows a diagram of action. Try to observe that effect of a force in as many situations as possible. You can also Add similar situation using available material from your environment. Note your observation in column 4 and 5 of the table. Okay, so here the table is given. If you have a NCERT textbook, then check page number 133 and we'll go for the activity. So first row is given a lump of a dough on the plate. Okay, so how to apply force? Pressing it down with your hands. Okay, then diagram is also given. Action of force, change in the state of motion, yes or no? Okay, so atta is not moving here and there, no? So there is a no change of movement, that is rest, that is also motion, no. And change of shape, yes, correct. Change in the state of motion will come, no. And here change in shape is yes. Okay, now second case, spring fixed to the seat of the bicycle by sitting on the seat. Okay, diagram is also given. The change state of motion, there is a no change of motion. Okay, not change of motion means what? Seat is like this, and when you will sit, then it will go little down, and that springs are there. The springs are what? Giving equal and opposite reaction to the object. Okay, there is a change of shape, no. There is a no change of shape takes place, no. Seat will remain as it is. So next one is what? Rubber band suspended from the hook or nail fixed on the wall. Okay, how to apply force? By hanging a weight or by pulling it free end. There is a change of action. Okay, rubber band suspended from the hook, and one part is fixed, then another is what? Hanging. That is yes. Change of state motion is yes. Change in the shape, yes. Whenever you are taking that rubber, we are stretching, there is a change in shape takes place by application of the force. Okay, and last one is there, a plastic or metal scale placed between two bricks and by putting weight at the center of the scale. Okay, means what? Here two books, they hold it like this. Okay, hold it like this, and they kept a page on it. Okay, so here they are keeping the object like this. Okay, and if something they are keeping heavy on this book, then that this small diary is what? Get a curved shape at midpoint. Okay, that means what? If any object we are keeping, that changes the shape of that object. That means what? Here change of state is there and change in shape is also there. Okay, so this is what? Activity 11.1. So from this we can conclude here. Check on page number 134. We can say here, may by application of a force, may it can make a object move from rest, may change the speed of an object if it is moving, may change the direction of a motion of an object, may bring about a change in the shape of an object, and may cause some or all of these effects. Okay, so this is nothing but what? Application of a force. So from this we can conclude force is a push or pull activity on the object, and because of the application of a force, there is what? The change in shape, change in size. It can, if the object is at rest, that will become in motion. If the object in motion, that will become into the rest. So these are the effects are there when you are applying force on any object. Can you getting? Then there are two types of contact forces are there. Means there are many different types of forces are there. First is contact forces and next is non-contact force. So contact force is nothing. In contact force, two forces are there. That is, first is a muscular force. What do you mean by muscular force? Muscular force is nothing but what? The action by the muscles, okay, is known as what? Muscular force. Suppose I have this highlighter with me, and I am keeping this highlighter over here, and I am applying force over here. This highlighter is what? Moving. Okay, so this if I am moving this hand also, what come into the action, my hand is what applying force on this. That means by just touching that object, okay, and once I touch and I am applying force, then that object is what moving. Means with the help of muscles I am moving that object. That's what here muscular force is there. And muscular force is a contact force. Why? Because this object can move only when we are applying the force on it. Can you getting this? Okay, so we push an object like a school bag. Okay, even the school bag is there, we are taking, we are lifting, and then we are keeping back. So whenever you are lifting, that means you are applying a force over there. Okay, that is known as muscular force. Then even the muscular force of animals is also used to carry out many difficult tasks. If you check on page number 134, last diagram, so they are carrying what, a load on their neck. Okay, means that bullock cart is there, and in that cart we are keeping many things, and they can carry all these goods or stuffs on them. So there is what, a muscular force is there by the buffalo or cows. Okay, so this is muscular force, and muscular force is also comes under contact force. Another contact force, very very important, that is a friction. Okay, friction, whenever we are walking there is a friction. Whenever you are erasing anything which you are written on your notebook with the help of pencil, that erasing action is also friction. Okay, when the car is moving on the road, the tire comes into the contact of road, is also one kind of friction. Okay, friction is one kind of force, okay, which opposes the motion. Okay, my original force is going like this, then friction is what, acting in the opposite direction. They will ask this question, okay, in assertion, reason, or true and false, or maybe in the definition. Friction is also one kind of contact force. Okay, and this friction is always acting in the opposite direction of a force, that is known as a frictional force. Okay, so friction, here they gave different examples, even I also explained that examples. Okay, so even wearing and tearing of the shoes, chappals, soles are there. After using, too many days or years, the chappal sole will become what, waste, so that is what, their heel part will become what, less. So that means there is a wear and tear of that rubber because of the friction. Okay, so this is what friction we learned up to here. And both friction and muscular forces are the contact forces, and tomorrow onwards we will go for non-contact forces. Okay, so this chapter is very big but very very important. Many questions will ask from this chapter. Okay, so today I will end this session, and then we can meet again tomorrow. Okay, so with the contact forces, the non-contact forces. Okay, thank you for joining. You can leave now. Okay, we can again meet tomorrow. Okay, thank you.
We had a